So we're looking at trinomials without an a value, so without a value in front of the x squared. So to start off, we're going to do it with algebra tiles. So we have one x squared tile, which we place in the top left-hand corner. Then we have 10 one tiles. So remember, we place all those ones in the bottom right-hand corner. And then we're going to fill in the spots that are left with 7 long x tiles. So I would start by trying to arrange these 10 ones in some formation that will allow me to place 7 x tiles. So if I place them like this, I'm going to be able to place 1 x tile, 2, 3, 4, 5, 6, and 7. So that works. And although my drawing is not rectangular, this would be a perfect rectangle if you were to use actual algebra tiles. So to find the factors, we look at the base and the height. So we're going to look at the dimensions. So the height here, there's a length of x and then 2 lengths of 1. So x plus 2 would be this height. And the base would be a length of x and then 1, 2, 3, 4, 5. So x plus 5. So the factors would be x plus 2 times x plus 5. When we try to do these problems algebraically, we're going to be looking for two numbers that multiply to give us the last numerical digit and that add to give us the x value. So we're looking for factors of negative 12 that are going to add or sum to negative 1. So I would start by just laying out some factors of negative 12. You could have 1 times negative 12. You could have negative 1 times 12. You could have 2 times 6, negative 6, negative 2 times 6. Or you could have 3 times negative 4, or negative 3 times 4. And obviously with time, the expectation is that you won't need to make this list. I'm just doing it here to show you. So if we were to add these same values, so if I took 1 and I added negative 12, I would end up with negative 11, which is not negative 1, so that won't work. Negative 1 plus 12 would give me positive 11, so that won't work. This would give me 2 plus negative 6, so I would get negative 4. Nope. Negative 2 plus 6 would give me positive 4, so that doesn't work. 3 plus negative 4 would give me negative 1. So we actually hit the right one, so I don't even need to calculate the last factor. So all this is telling us is that the factor of x squared minus x minus 12 is going to be x plus 3, x minus 4. The way that I could complicate a problem would be to give you something like this. So before you start any factoring problem, you should identify if there is a greatest common factor, and if there is, you need to factor it out. So in this case, 4, 20, and negative 24 are all divisible by 4. And then we have x cubed, x squared, and x. So they all also contain an x. So the greatest common factor here would be 4x, which would leave me with x squared plus 5x minus 6. And now I have to look at what's left here in the brackets, because if it's something that can be factored further, you're expected to continue factoring. So in this case, I would analyze to see, are there two numbers that multiply to give me negative 6, but add to give me 5? So I'm looking for factors of negative 6. Luckily, there aren't too many here. We could end up with 1 times negative 6, negative 1 times 6, 2 times negative 3, or negative 3 times 2. So in this case, if I were to add this one here, if I added 1 plus negative 6, I would end up with negative 5. If I were to add here, I would end up with 5, and I need positive 5, so this is the case that works. So I don't even need to calculate the last two. So my final factors would have that x minus, oh sorry, I put the wrong numbers down, but the x minus 1 and the x plus 6 that we got from doing this process. But I can't forget that I had originally factored out 4x, so it is still a part of my solution. So this would be the factors of 4x cubed plus 20x squared minus 24x.